Mastering cubic polynomials, specifically nailing that crucial product of a linear and a quadratic factor. Look, this is absolutely paramount for your Cambridge 0606 success. Today's explainer breaks down the exact step-by-step high-mark strategy to secure your grade in this literally guaranteed exam topic. Let's get right to it.
Okay, let's dive into this by shattering the single biggest study myth out there. If you're thinking that only the final correct numerical answer matters on your exam paper, honestly, you're setting yourself up for a really bad time. Rote memorization of final formulas is just going to fail you when the pressure's on. The absolute truth, and this is straight from the examiners themselves, is that process is everything. I mean, let me escalate the stakes for you right now. Take a look at this number, 0. Yep, 0. That is the exact number of marks you'll get if you provide a totally correct final answer, but don't show you're working on these polynomial questions. None. You're literally risking your entire grade boundary if you just scribble down the final linear and quadratic factors without the clear mathematical proof to back it up. So, what exactly is the core task we're tackling? Well, it's finding the factors of cubic polynomials. Basically, obtaining the product of a linear factor and a quadratic factor. You can do this by observation or, through algebraic long division. And listen, this isn't just some optional extra. This specific topic appears in every single exam series. It absolutely demands a total mastery of fundamental algebraic principles. Now, listen to this direct quote from the Cambridge Principal Examiner reports. Candidates referencing cross-topic connections achieve significantly higher marks. As an exam coach, I can tell you this is a huge deal. Top-performing students, they don't just memorize isolated bits of knowledge like it's a grocery list. They show a connected, conceptual understanding. When you start linking polynomial division to factor theorems and graphical roots, boom, you instantly step right into those top-tier marking bands. To grab those marks, we really need to understand how we're actually being tested. Examiners are targeting 3 distinct cognitive domains here: knowledge and understanding, application, and critical analysis. Now, most of us grasp the knowledge part pretty easily, right? But students completely freeze up on critical analysis. Evaluating evidence, extracting data from the text, checking if an answer is reasonable. It's incredibly difficult for a lot of people. Why? Because it requires you to actively deconstruct the problem rather than just passively plugging numbers into some memorized formula. Which brings us to a massive question. What critical examiner clue completely changes your final answer? In just a minute, I'm going to show you a huge format mistake that literally ruins otherwise perfect algebraic long division calculations. It's a trap so many students fall into. But hey, before I reveal that clue, you need the procedural framework first. It's going to make spotting that trap completely obvious. And this brilliantly illustrates why you need a strict procedural framework. It's like a giant puzzle. It starts by identifying the key elements of your cubic, which lets you seamlessly apply relevant principles, like the factor theorem. From there, you execute your analysis with clear algebraic long division. Verify your results to make sure they're actually reasonable, and finally, present everything in the exact required format. Systematic processing is, for sure, the only way to successfully deconstruct an exam question. Let's look at a high-stakes comparison so you can see exactly how this builds your score. On the left side here, we have a flawed bottom-band student answer that just spits out the final factors. But on the right, the top-band answer shows the step-by-step algebraic long division. It explicitly details how they arrived at both the linear and quadratic factors. Now the left side gets 0 marks. Yup, even if the math in their head was entirely correct. But the right side? That secures full marks because the whole shebang, the entire process, is completely transparent to the examiner. But even with your working shown, easy marks can still slip away. The examiner reports consistently warn us about 3 major pitfalls. First, students routinely forget the proper format, leaving their answers as a scattered jumble of terms instead of a nice, clean product of a linear and a quadratic factor. Second, messy presentation during the algebraic division itself just leads to easily misread signs. A plus becomes a minus, and it's game over. And finally, students just fail to tailor their answers specifically to the context provided by the question. This really highlights what we like to call the method mark strategy. Basically, process equals marks. Think about it. Even if your final calculation is completely wrong, say you messed up a really simple addition right at the very end of your long division, just demonstrating the correct procedure through clear, systematic notation can mathematically save a failing grade. It really can. Examiners actively award method marks just for utilizing the correct analytical framework. Now, I get it. Keeping all those steps straight under intense exam pressure can be really tough. So here's a brilliant little memory hack for you: the visual story method.
To encode the complex steps of algebraic long division, just turn it into a mental visual story. Imagine the cubic polynomial as this giant solid block of ice. The linear factor is the ice pick you're using to chip away that first chunk. And the quadratic factor? That's the complex, beautiful sculpture left behind. Actually visualizing the physical breakdown of the equation like this helps encode the step-by-step process deep down into your long-term memory.
So, the crucial point is finally here. Remember that open loop I mentioned earlier about the examiner clue that changes absolutely everything? Well, the clue is extracting the specific analytical framework and context directly from the question text itself. The exact wording of the question dictates your format. If the question specifically asks you to find the roots, well, stopping at just the factors is going to lose you marks. Reading those specific constraints carefully prevents catastrophic errors and ensures your flawless calculation actually answers what was asked. To make sure you never miss these critical insights, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Doing this right now ensures you have direct, immediate access to the elite exam strategies you absolutely need to succeed. We've completely replaced the myth of just memorizing answers with a proven examiner-approved system today. But this leaves us with a massive unresolved problem. You now have the high-mark strategy for cubic polynomials. But how do you map this system out across all your topics in the last 7 days of revision? How do you ensure this system actually sticks when the clock is ticking down and the pressure is on? Well, that is exactly what we are going to solve in our next explainer on the last 7 days revision map. See you there.